Hi class, welcome to Math is Fundamental. Today we're going to learn all about the angle-side angle and angle-angle-side triangle congruence postulates. So let's start with the first one. Angle-side angle postulate states if two angles in the included side of one triangle are congruent to two angles in the included side of another triangle, then the two triangles are congruent. And that's a really long postulate definition. So let's use our diagram and really figure out what that says. So here I have two angles in the included side. So what that means is if I have two angles here, the included side is the side in between those two angles. So here would be my included side. So now I just need to make sure that I have a matching two angles and included side in the other triangle. So here is my matching two angles and included side on my other triangle. If I have all that information, then I can use angle-side angle to say that my triangles are congruent. All right, next we have angle-angle-side, which states if two angles and a non-included side of one triangle. So here it's a little different. Here's my two angles, but now I want a side that's not in between them. For example, this one. If those are congruent to two angles in the corresponding non-included side of another triangle, then the two triangles are congruent. So the only thing you need to really be careful of here is if I have my two angles and I'm looking at the other side of the other triangle, I need to make sure that it's a corresponding side. So it has to be this one. It can't be any of the other sides on that triangle, or it wouldn't really match up. All right, so here we have a little note. These two postulates are used when trying to prove that triangles are congruent. And I know that might seem a little obvious for you, but we want to make that note because later on when we learn more theorems, it starts to get a little confusing. So any of these little notes we can write down will help us later. Okay, so we now have four ways to prove that triangles are congruent other than using the definition of congruent triangles, which the definition requires us to use all 6 corresponding parts. So we have 4 ways other than that to prove this. Today we learned our angle, it was angle-side angle, and we learned angle-angle-side, and in the last video we talked about side-side-side and side-angle-side. So here's the 4 things we can look at now when we're trying to figure out why two triangles are congruent to each other. All right, so for each one of these diagrams, we're going to figure out, can we decide if they're congruent to each other, and which theorem are we going to use to prove it? So if we look at our first one, we have 2 sets of angles and 1 side. So if we look at our list, we want to look for which group of 3 letters has 2 A's and 1 S. So it's either going to be angle-side angle or angle-angle-side. So we need to figure out which one is it, or is it neither one of them? We have to be careful. All right, so let's look. So here, ASA, where the S is in the middle of the A's, it means that the side has to be in between the 2 angles. Well, if we look at our diagram, that side that's marked is not in between the 2 angles that are marked. So now we're going to look at ASA. So I know that angle-side angle is not going to work. AAS, we have 2 angles and a side not included, or not in between the 2 angles, but it has to be a corresponding side. So here, if we look at our diagram, we have 2 sets of angles, and sure enough, we have a corresponding side. So yes, they're congruent by angle, angle, side, for example A. All right, example B, we have 2 sets of sides that were given, and we're actually not given any more information. So there might be some hidden information in the triangle. So let's look. If we already have 2 sets of sides, I know it's going to be either SSS or SAS, or it might be neither one of them. It might be, no, they're not congruent. So we have to really look at these triangles. So let's see. SAS means, well, I would need the included angle. I'm going to draw it on the triangles, but it might not be true. So let's see. If I had that included angle, this would give me side angle side, but how or why, how do we know that those 2 angles are congruent? there's really nothing telling us that those two angles are congruent. And we cannot simply, jumped down to the end, we cannot simply assume or hope that they're congruent. We have to know for sure and have a valid reason why they're congruent. So I'm pretty sure SAS is out of the picture for this example. Now SSS means that I would need this third side to be congruent for both triangles. And lucky for us, we've covered this before in some of our previous videos. When we have two triangles that are overlapping or touching in some way, a lot of the time they share common parts. And here we're sharing a common side. So these two triangles, that totally works. We would use reflexive property of congruence for that third side. So we would have yes, by side, side, side. These triangles are congruent. All right, let's look at C. So again, I have two sets of sides and one set of angles. So is it, well, let's look. I have side, side, angle, or sorry, side, 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 or side, angle, side. So side, 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 or side, angle, side. Well, I have two sets of sides and one angle, so that means side, side, side is out because I have an angle, but is it side, angle, side? Well, because SAS, the order of the letters, implies A, the angle has to be in between the two marked sides. And if we look at our diagram, it's not. The angle that we would need would be here and here. Those would give us the angle in between the sides, but that's not the one that we were given in this problem. So, let me put our little marking back here. So it's not side, angle, side either, which means it's neither one. So no. If we try to make our own letters with this information and we go around our triangle, we would have a side, and then an angle, and that doesn't work in geometry. In math, this is not enough to show that two triangles are congruent, so we can't use it. All right, and then for example D, our last one, we have two sets of sides given to us already. So we want to think, okay, side, 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 or side, angle, side. All right, so, well, let's look at that third set of sides. Can we say that this side is congruent to this one? Well, I don't really have anything telling me that they're congruent. It's not a shared common side, and just because they look congruent doesn't mean they are. So that one isn't going to work. That one's out. I can't just hope or pray that they're congruent. All right, well, let's look at side, angle, side. Is the angle in between the two sides congruent? And if we dig way back when into like the first chapter that we were doing, we learned vertical angles. And vertical angles are always congruent. So here, that works. We have vertical angles theorem to tell us that that's true, always, always. So yes, these are congruent by side, angle, side for this example. All right, so let's close our lesson with one proof. Let's do a proof here. More proof practice, the better. So here we are given, and we always want to draw it on our diagram, that angle EDF is congruent to angle DFG. So there they're marked. And segment EF is parallel to segment DG. All right, so that's our given information. Let's write it into our proof. So angle EDF is congruent to angle DFG, and segment EF is parallel to segment DG. And our reason, again, is just the word given because that's what they gave us. Okay, second line. Now we have to think, what else can I figure out from this diagram? Well, we know from what we learned before that if two triangles are touching or overlapping, chances are there's a shared part. So this side here, DF, is a shared part of both of these two triangles. I know that DF is congruent to itself, DF. And our reason, we have to think about all those theorems and properties. This one is the reflexive property of congruence. So by the reflexive property, just like it's looking in the mirror right at itself, its reflection, we have DF is congruent to DF. So now I have one set of angles, I have one set of sides, I need one more piece of information. I need 3 parts in order to get to one of those postulates we've learned. So we have another piece of information here, these parallel sides. And anytime we see parallel sides in a proof like this, we want to think about the angles. It's going to give us some information about the angles. We learned in some videos previous to this one that if I have 2 parallel lines in a transversal, I have lots of different angles that are congruent based on different theorems. So in this diagram, I can use alternate interior angles here to show that those angles are congruent. And if you're not seeing it, I'll take my green marker and I'll outline the lines. So if this one and this one are 2 parallel lines, because they told us they were parallel, and this is my transversal here, then I have alternate interior angles. So if we look back at this other picture I drew, I know it's so hard to see these sometimes. Let me draw those out here. So here's our 2 lines and our transversal. The 2 angles I just marked is this one and this one. Those are alternate interior angles. So that's what we're using in our proof right now. All right, so let's see. We have angle EFD is congruent to angle FDG by the alternate interior angles theorem, abbreviating a lot of things. All right, and then if we look back at our picture, we now have 2 sets of angles and the included side congruent for our 2 triangles. So that gives us 2 sets of angles and the included side congruent in our 2 triangles, which means we're done. We just have to close our proof. Triangle EFD is congruent to triangle GDF. All right, and that concludes our lesson for today. So thank you so much for watching, and remember, math is fundamental.